Suppose there are two rails like this, very long rails are there. Control C, Control V. So there are two very long rails which are there till infinity. So that's why. Let's name these rails as A and 9. Let's name it as 9. So is this clear, guys? Two rails, P and Q. P and Q are very long, and they are frictionless. So basically, they have given whatever data is there, they have given it in word format, but I'm not writing the full thing. They are separated by a distance L. Distance between P and Q is basically L, right? Their ends are joined with a resistance capital R. So can you see their ends? This end is joined with a resistance capital R, and a connector AB, and there is a connector AB which I'll draw like this. I don't know how I'll fill color in this, but can you see a connector AB? Guys, can you see connector AB? Is a resistance-less connector placed over P and Q. Is this clear? Guys, can you see this connector AB can slide freely over the rails? Now this connector is pulled with a constant velocity V. Connector is pulled with a constant velocity V. In a magnetic field as shown in the figure. So can everyone see a magnetic field over here? Yes or no? Everyone is able to see a magnetic field, right?
Yes, sir.
So the magnetic field is acting into the plane, and you are pulling a connector towards the right. So basically magnetic field lines will be cut, right? When magnetic field lines will be cut, what will happen? An EMF will be generated over here, and due to EMF generation, what will happen? A current will flow through this thing, right? So now the question is, first calculate the current through R, through the resistance R. Second part is an external agent is required to apply a force on a conductor to move it with a constant velocity. Find the force applied by the external agent. Third, calculate the electrical power developed in the चलो शुरू हो जाओ. Draw the question once. First of all, concepts. Guys, what all concepts are involved over here? Can you see when the connector AB will move over the rails P and Q, what will happen? Magnetic field lines will be cut, right? Yes or no? Will magnetic field lines will be cut? Hello? Hello, guys?
Yes.
Yes, sir.
So basically what will happen? The magnetic field lines will be cut. When magnetic field lines will be cut, what will happen? An EMF will be induced. What will be the magnitude of that EMF? EMF will be equals to B into V into L, right? That will be the EMF. Due to that EMF, a current will start flowing through this thing, right? A current will flow through the loop. Can you see over here this loop, right? Now when a current will flow through that loop, what will happen? There will be a magnetic force which will be experienced by this AB, right? Find the direction of that AB and you will see that the direction of that magnetic force is opposite to B. So that is why it is necessary to pull it with by applying certain external force so that it may go with a constant velocity. First of all, by motional EMF, what will happen? I'll just copy the diagram again. You don't need to copy the diagram again. See. So basically, what will be the EMF across AB? Acha, which will be bigger? Will A be bigger or will B be bigger? Do you remember right hand palm rule? Just give me one. हेलो. हाँ, मेरी क्लास चल रही है. क्लास चल रही है. मम्मी मम्मी को मम्मी के फोन. हाँ मैं बोल देता हूँ. Guys, just give me 2 minutes. Let me give my mom her phone. 2 minutes. I'll be back. Yes, hello guys. Hello.
Yes, sir.
Yes. So basically, will apply a right hand thumb rule. Oh, sorry, right hand palm rule. So by right hand palm rule, can you tell me which will be bigger? Will A be bigger or will B be bigger? Thumb
A.
in the direction towards
A.
left. Next, sorry, right. Magnetic field fingertips into the plane, right? So basically, from here you will see your palm will face towards A. So when palm will face towards A, that implies VA should be greater than VB. So now what will be VA minus VB? That will be equals to B into L into V, right? Because can you see the length vector is making an angle 90 degree with the velocity. So B into L into V. Yes? Once you're done with this, what will we do? Guys? will this be the potential difference? So hence current,
Mm.
this will be positive, this will be negative. So basically current will flow through this direction, right? Inside the battery from negative to positive, right? Yes or no? And this thing will be
Yes, sir.
something like this. This point is your A, this point is your B, and it will act as a battery like this. Are you getting my point? So that is why A was positive and B was negative, and hence the current is flowing from here to here. So now what will be the current? The first part of the question, the current will be equals to VA minus VB divided by R, which is VLB. So this is the answer for the first part of the question. Is this clear, guys? First part clear? Now what happens when a current flows through this thing? Can you see there is a current carrying rod, and this current carrying rod is there inside a magnetic field, so it will experience the Lorentz magnetic force, right? So can you see Fm is equals to L cross B? So there will be a magnetic force acting in this direction due to the current, a magnetic force Fm, which is equals to B into I into L, is applied on the connector area. So Fm will be equals to B into small I into L, which will be equals to B into I. So can you see this force? Yes or no? Can you see this magnetic force? Now, since I want to move this with a constant velocity, so for constant velocity, the forces should be balanced. So that is why I was applying an external force in the opposite direction of Fm, such that this and this should be equal. So to maintain a constant velocity, according to the question only, to maintain a constant velocity, F external should be equals to Fm magnitude. So this will be equals to, this is the answer for the second part of the question. Is this clear, guys? Second part.
Yes, sir.
Now third part is what? Third part is basically what is the power delivered by the power delivered to the external resistance. The power will be equals to I square into R. So I will be equals to V L upon R square into R. So when you do this, it will be V square L square. Acha, tell me who is providing this power? Is there a battery here? Power delivered to the resistor. If someone asks you what is the power delivered by the external agent, will it be the same thing? V square L square upon R. Yes or no, guys? Will the power delivered by the external agent, will it be the same as this? Yes or no? Because this external agent will be doing the necessary work, and whatever work is being done, basically whatever power is being consumed or basically provided is being consumed by the resistor. Simple. Can you see? Both are one and the same. Okay. But can you see over here? This is power delivered to the resistor and delivered by the external agent. So please pay attention on this. Sure. Done. Last question on this, and then we'll do something else. Other no, we'll see one more thing. Are you done? Done, guys. If you're done with this, then we'll do the next question.
Yes, so done.
Sure. Question is, a wire bent as a parabola y equals to kx square is located in a uniform magnetic field B. At time t equals to 0, the connector, it's the same question as the previous one, but in just in case I'm doing something else, I'll just draw the diagram as well. The connector starts sliding translationally with a constant acceleration from the vertex of the parabola at origin. So the question is, find the EMF produced in the loop as a function of y. Yes, guys, everyone can see a parabola, right? Y equals to kx square. This is the parabola y equals to kx square. And now they have said that they have a connector which starts yes, guys, everyone can see a connector, right? So this connector is moving in this direction with an acceleration a. This is the y coordinate of the connector at any time. This connector is infinitely long, so don't think like, sir, after one time it will be out of coverage area. No, it will be always in contact with the rails. Okay. Magnetic field is acting into the plane at every point. The magnetic field is acting into the plane. Now the question is, we find the EMF induced across these 2 points. Can you see? Because this is moving with certain velocity, right? Since it is moving with a constant acceleration, then velocity will also be a function of time. So think and do it a little bit. Initially, it is at rest. Initially, it is at rest over here. Yeah, on x-axis, it is at rest. And then it starts moving with an acceleration, uniform acceleration. The acceleration is basically plus a time. If I say time is t, then or in spite of doing it with time, let's say at a displacement y, what is the velocity? VUAS. Can anyone apply third equation of motion? V is equals to V square equals to U square plus 2AS. So V square is what we need to find. U square is 0 twice A Y under root. This is the velocity at height Y. Yes or no? Guys, did you understand that when it started with a constant acceleration A at a displacement Y, the velocity will become this much? Yes or no?
Yes, sir.
Velocity at a displacement Y. Once you calculate the velocity, you know with what velocity it is moving, right? So you will do what? EMF will be equals to B into L into V, right? V is basically this, but do you know the length? Guys, do you know the length of this thing? Do you know the length of the conductor at any general time or at any general? Can you see this length is, what is this length? Is it given in the question? No, this will keep on changing, right? Everyone knows the parabola looks like this. So once this thing moves, keeps on moving, at different positions. So can you see the length will keep on increasing? Initially the length is this, then the length will be this, then the length will be this. So can you see, guys, the length will keep on increasing. So basically you need to find out the general length of this thing when it is at a distance y. So how will we do it? How will we do it? Math student, can you tell me what will be the length of this thing?
So will it be 2x?
2x, where what is x?
Yeah, x is the point, yeah.
But
Like where it is intersecting the parabola.
2x. This distance is y. What is x?
Will be root of y by k.
Will we do what?
Root of y by k.
Root of y by k. Yes, it will be root of y by k. Why it will be root of y by k? Can you see over here, guys? This distance is basically the x coordinate, right? This is also x and this is also x. If you can find out this x, then this length will be nothing but 2x, right? So we know this thing for which, if we can just find out what is the x coordinate at a distance y, then automatically we can get our answer. And where will we get the x coordinate is from the equation. Do you remember this was given as y equals to kx square? If y is equals to kx square, then x square is equals to y by k, and from here x is equals to under root of y by k, and that too plus minus. So can you see this is x equals to plus under root of y by k, and this is x under root of minus of y by. So what is this distance, guys? This distance is nothing but y by k, right? Under root of y by k. So from here, L will be twice of under root of y by k, and you'll put this over here. So E will be equals to B into twice of under root y by k into velocity. Velocity was equals to twice under root of 2ay. This will be E will be equals to twice of B, and root y will be getting multiplied, and then y will come out, and this will be twice of A by, and that will be the answer. Clear? Is this clear, guys? Is this clear? So I'll give you second
Yes,
part
sir.
of this as a homework. Find the EMF as a function of time. The final answer should be V T cube twice of A cube upon K. I think so. This is the answer. Because I don't have the solution to it, but just a statement written in my notes. So this is a homework question for you people. Try to do it. In terms of time, you need to calculate. So is this clear, guys? I think I have done enough on these questions. Motional EMF under external power. Okay. Clear, guys? How are your vacations going on, guys? Guys, how are your vacations going on? कोई बोलता ही नहीं है. जा, कोई. Please write down heading. EMF induced in a rotating conductor in uniform magnetic. Okay, so suppose this. I have a rod PQ, and this time the rod is not moving translately, but it is rotating with an angular velocity omega. The rod has a length L. I think this is a part of your syllabus, so I'll do that. Let us consider a rod PQ of length L rotating in circular motion about an axis passing through P perpendicular to the plane of Earth with an angular velocity omega. So when it is rotating with an angular velocity omega, then what will be happening? Will this be the circular motion it will be performing, right? The whole rod. Can you see this rod will be covering up the area of this much, right? Although it doesn't have anything to do with the area, but still. So now the question is find the EMF across. When the rod is like this, suppose if I have the magnetic field like this is the magnetic field. This is placed in a uniform magnetic field. Okay, so this is the magnetic field B, and can you see it is rotating with an angular velocity omega. So can you see over here when this rod will rotate, lines will be cut? Yes or no? Yes or no? Will the lines be cut?
Yes, sir.
So if the lines will be cut, then what will happen? If lines will be cut, then what will happen? It will.
EMF will be induced.
Guys, just give me 2 minutes. It will, induce an EMF across PN. Let me just. Hello, can you hear me?
Yes, sir.
Yes.
चलिए चलिए. So now what is happening? When we are considering this rod PQ, when this rod is rotating, then what is happening? Every element on the rod, can you see it is cutting the lines, right or wrong? Here in the case of this rod, but there is just one single difference. What was happening in the case when the rod is moving translationally? When the rod moves translationally, then every element moves with the same velocity v, right? Even this moves with the same velocity v. This also moves with the same velocity v. This also moves with the same velocity v, right? But what is happening in this case when the rod is rotating about an axis, then what will be happening due to circular motion? We know this particular thing, na? Everyone knows this formula. The linear velocity is basically v is equals to r into omega, and every element over here will have the same angular speed but different linear speed, right? So here every element will have a different linear speed. The element which is near the axis will have the least speed, whereas the element which is have away from the axis of rotation will have the greatest speed. So in this case, what will we do? We'll consider a small length element. Let us consider a small elemental length at a distance x from the axis of rotation, having width dx, and can anyone tell me what is the velocity with which this small element will be moving? Can anyone tell me what will be the velocity with this with which this thing will be moving? What will be the velocity of this thing? Will the velocity be equals to r omega? R is basically the distance from the axis of rotation. Here the distance will be x. So velocity will be x into omega. So this is the velocity, right? Yes or no? Are yes or no, guys? Let's name it mn.
Yes, sir.
Small elemental length mn. Now, can anyone apply right hand thumb rule to mn? Right hand palm rule. On applying right hand palm rule on mn, who will apply right hand palm rule on mn and tell me which end is positive? M is positive or n is positive? Which end is positive? Yes, Vaishnavi, please tell me which end is positive. Is M positive? M is the end which is lying closer to the center, or basically closer to the axis of rotation, and N is away from the axis of rotation. Can you tell me which end will be positive? Hello. Hello. Is Vaishnavi here? Yes, Arya, can you tell me please? Shrishma, can you tell me?
So the end M will be positive.
The end M will be positive. Why it will be positive? Because when I'll move my thumb, the thumb will be pointing in the direction of V, and then what will happen? Magnetic field is reacting into the plane, so hence my palm passes to it points towards M, right? Sir, my mic doesn't work. Okay, no problem. So due to which what will happen? M will be positive. So when M will be positive, automatically P will also become positive. Because when you will add all of the small cells, it will be there in series. So VM is greater than, so Vm minus Vn will it be equals to B into V into what is the length of this thing? L. So can you see BV into L? The length of that small element, yes or no? The length was dx, the velocity was v, and the magnetic field was into the plane. So v dx. Yes. So when you have this, v will be equals to what? V was equals to x omega into dx. So this is your EMN. Now can you see over here, guys, this small element, it behaves as a small battery or small e, DE, you can name it as DE, right? So when you integrate this DE over Mn, then it becomes the EMF across the whole PQ rod. Yes or no? When you integrate all the elements, it will become across P and Q. So DEMN will be equals to this, hence it will be B omega x dx ka integration from where to where? From 0 to L. Sir, why the limits are from 0 to L? Because the first element is over here and the last element is over here at a distance L. So from here, when I solve, the EMF across rod PQ will be equals to half B omega L square. Please note it down. Is this clear, guys?
Yes, sir.
Please note for a conducting disc also. For a conducting disc, radius is R. Radius R rotating about its axis. So the EMF across PQ will be, suppose if I have a yes, can you see a disc? So suppose, guys, if this disc is rotating about its central axis like this with the angular speed omega, this disc, if it has a radius r, then the EMF across these 2 points, can you see? Across the center and across the point on its circumference. EMF across PQ is basically half B omega r square. Same thing. If someone asks you if there is a disk rotating and what is the EMF across a point at its center and the circumference, then what will be your answer? The answer will be half B omega r square. Clear? Clear, guys?
Yes, sir.
Now suppose there are lots of special cases involved. Suppose if the rod is not rotating about one of its ends, if the rod is rotating about its center, if the rod is rotating like this about its center, And if someone asks you what is the, this is PQ, and let's say the center is O, and the rod is rotating with the angular velocity omega. So if someone asks you what is the EMF across PQ, then what will be your answer? Will it be the same as previous case, or will it be different? The EMF will be across P and Q will be 0. Why? Because the potential of point P and the potential of point Q will be equal to each other. Is this clear? Why, sir? Why will the potential be equal? The potential will be equal because, can you see over here, this, in this case, this is, suppose just consider this as two different rods, right? There is a rod OQ and there is a rod OP, right? If suppose if PQ has a length L, then OQ has a length L by 2, and this also has a length L by 2. If someone asks you what is the EMF across point EO minus EQ, oh sorry, the potential O minus OQ. Sir, why are you taking this as big? Because I'm doing the same thing as previous case. The direction, sense of rotation, everything is same. Can you see the EMF across OQ is OQ, and the EMF across P is PQ. This will be equals to half of B omega length. What is the length of this rod? L by 2, right? Please remember this thing, guys. So can you see over here, since the difference in the EMF is also equal, hence VQ and VP are equal to each other. If VP and VQ are equal to each other, then hence the EMF across P and Q is 0. Are you getting my point? So thoda sa, a little bit trick is there, but I think it's solved. Please note it down. Once you're done, just tell me. Done. Whenever you're done. So is this clear, guys? Now, if someone asks you, ki, special case, suppose again, if this is the rod, the same rod is there. And let's say this rod is rotating about this one, point P and Q. But I don't want this. I want, this is M. The distance is X. The rod is rotating about P, about point P, but I want what is the potential difference across, what is the EMF across M and Q. Okay, basically I want Vm minus Vq. Yes, what will be your approach to solve it? Anyone? What will be your approach to do this? See, you will do the same thing again. You will choose the same small element, you will choose the same everything. Only the difference will be the limits. You wanted the potential difference across P and Q. That's why the limit you chose was from 0 to L. If you don't want to choose the center, you want to choose a distance x, then what will be the case? The EMF across MQ will be d omega x dx, and let's take it small n. Okay, so small n to capital. Clear? Please note it down. And in all the cases, the magnetic field is like this only. Because the direction, I know you people can apply the right hand palm rule and get the direction easily. Take. Hello guys, done? Acha,
Yes, sir.
there is one more thing. Suppose if the rod is not straight, what if the rod is like it's a wire, and the wire is random shaped wire. Let's say the wire is like this. This is point P, this is point Q, and now the wire is of random shaped, and this wire is rotating with an angular velocity omega. Then what will be the EMF across P and Q? What will you do? You remember the case when you joined P and Q and this length was L. So the EMF
Yes,
across
sir.
PQ will be equals to the same as half B omega cos phi L square. And you see, you can assume this as a straight wire. Okay. If someone gives you a question that there is a semicircular wire like this, which is rotating about an axis P, this is P, and it is rotating with an angular speed omega. This has a radius r. Fine. Motional EMF across P and Q. Yes, guys, tell me. Which end will be at higher potential, P or Q?
Q.
Now Q
Q.
will be at higher potential. Why? Because first thing first, you will assume this as a rod of length how much? What will be the distance between?
2R.
So basically the length of the rod will be 2r. This thing is rotating with omega over here, magnetic field is over here. So basically, can you see this is rotating like this, then the velocity vector will be in this direction, right? So your thumb should be pointing upwards, your fingertip should be pointing towards you, velocity should be upwards, the thumb should be upwards, and fingertip should be pointing towards you. Then you'll see your palm of right hand is pointing towards, sorry. So this is positive and this is negative. The EMF across PQ, or basically in this case QB, half B omega into. Is this clear, guys?
Yes, sir.
I'll give you next question. Yes, can you see a semicircular wire loop? This is a semicircular wire loop. Resistance is capital R and radius is A. This radius is A, okay? And can you see it is hinged about its center? What do you mean by hinged about its center?
Fixed at the center.
It can rotate about the center. It can rotate about an axis which is passing through the center, okay? So this is hinged about point O, and this is rotating with an angular speed omega. Yes. So can you see this circular loop is rotating at an angular speed omega? Now can you see over here point O is located at the boundary of a uniform magnetic field. This area has magnetic field data. Yes. So this area has a magnetic field. When it will rotate, can you see over here, when it will rotate, this part which is there inside the magnetic field, it will keep on increasing, right? So when the loop is like this, was there any magnetic field over here? Guys, was there any magnetic flux in this case? First case? Zero, right? But can you see when it starts entering, so can you see this much area is now there inside the magnetic field and it is increasing, right? So here the flux increases. So matlab, if flux is increases, that implies flux is changing. If flux is changing, then what will happen? There will be a current induced. Yes or no? Hi Anna, you understood the gist of the question, right?
Yes, sir.
Now basically what will happen, this will turn, this will increase till the time the loop will become like this, right? At this particular time the phi will become maximum and then it will start coming out, right? So can you see now only this much part is there inside the loop. So when it is at this position, now the flux will start decreasing till the time it doesn't become zero again. Are you getting my point, guys? The question सबको समझ में आया? What is the question, right?
Yes.
Now the question over here is, everyone understood the rotation. How is the rotation of this circular loop happening? Now the question is, plot the current as a function of time. Assume clockwise current as positive. Okay. Initially it is like this. This is how it is initially. So basically you need to find out what is the graph basically. Okay. Giving it 2 minutes. Try to solve. Yes, किसी ने कुछ सोचा? See guys, didn't know this particular thing. How will be the current? Please remember. Can you see over here? This semicircular part. Will it be cutting any lines? Will the semicircular part cut any line? Guys, even if it's a loop, but can you see over here? Since the semicircular part is of negligible thickness, and on rotating about O, it will not cut any line, any magnetic field line. Hence, no EMF is produced in it. right? Yes or no? Yes or no, guys? So here, what will be the when the loop will be like this? Can you see over here? This part is out of the magnetic field. O, let's name it as P, and let's name it as Q. So can you see OP part is out of the magnetic field? It will not produce anything. PQ is semicircular and it is parallel to the magnetic field. Parallel, we can say not parallel, but it will not cut any line, right? The only thing which will cut the line is basically this part OQ. Only OQ will cut the line. Hence, the EMF across OQ will be equals to, what will be the EMF across OQ? Half B omega R square, right? Because the length of OQ is nothing but R. And which will be bigger? Q will be bigger, or Q will be bigger, or O will be bigger? Which will be bigger? Q will be the bigger one, and O will be the, so VQ minus O is equals to half B omega R square. Now this is the EMF. If this is the EMF, not R, sorry, A. The radius was A, right? So half B omega A square. Now we know this particular thing, induced current is nothing but E divided by the resistance of the whole loop. The resistance of the whole loop was given as R, so it is basically E omega A square by 2R. This is your induced current. Can you see magnetic field was constant, it was rotating with a constant angular velocity, the resistance is constant, so this whole thing is a constant. Yes or no? So this whole thing is a constant, and the graph will be a straight line. And since this is the case, this Q is bigger than O, then I can suppose this particular thing. It's something like this. Okay. So can you see over here the current in this case will be in what direction? Clockwise, anti-clockwise? This will be anti-clockwise first, right? So when I draw the graph, it will start from the bottom first till the time it doesn't become zero. Okay. So till the time we don't reach here, till the time we don't reach here, the current will go over there. And when it will start coming out, the current will be in the opposite. If you want, you can check. And this process will repeat again and again. So basically, this is the graph for current versus time. So sometimes questions like this can be asked. Please go through it once.
So why do we say it as constant?
Because B was constant. Every term which is there in current is constant. Right? We are not changing the magnetic field. We are not increasing or decreasing the angular speed. The radius is same. The capital R is constant, right?
Okay.
Clear, guys? Shall I give you one more question, guys? Last question on this, then we'll start with the induction part, self-induction, mutual induction part. So, guys, can you see a loop over here? Everyone is able to see a loop, current carrying loop, right? Now, this current carrying loop, can you see over here this magnetic field? There is magnetic field only in the part where there is this semicircle. And figure shows a conducting loop of which semicircular part lies in the magnetic field, which varies with time as B is equals to AT cube plus CT square plus F. So basically, this is the magnetic field, Tesla. Okay. The wire is having a resistance. The resistance of wire per unit length of wire is lambda ohm per meter. You need to find out what is the current in this loop. I'll just give you some values. 5t cube, this will, let's say 8t square, and let's say this is the values is fine. The value and this lambda, let's say it is 5 ohm per meter. The radius is, let's say, 2 by 5 meter. Array. Okay, guys, please solve. Magnetic field is given, right? So this is the question. Can you see the magnetic field is dependent on time? So this is a question on time varying magnetic field. And they are saying the resistance per unit length of the wire is 5 ohm per meter and find the current in the loop. First of all, let's find out what is the resistance of the whole thing. Resistance will be equals to what? Can you see over here? This length will be 2 meter and they have given this radius as r meter. So can you see over here this radius is r, then what will be this length? what will be this then, guys? Will it be equals to pi into r? Yes. So this will be pi r. This length will be 2 meter. So, and let's say this is, guys, the question is something like this. This part from A to B only they have resistance, and A to B throughout the battery it doesn't have any resistance. So pi r plus 4 is the resistance, is the length multiplied by lambda, which is basically 5 ohms per meter. So basically we are calculating the resistance first. Pi into 2 by pi plus 4 to the 5 omega, and this will be 30. So the resistance of the wire is basically 30 ohm. We said ki A to B is resistance less. Okay. Now, can you see over here the magnetic field is varying with time? So if the magnetic field is varying with time, then the flux will be equals to Q multiplied by A, which will be equals to, what is the magnetic field? 5 PQ plus 8 T square plus multiplied by area is pi r square, because only that area is inside the magnetic field. Pi r square divided by 2, because we only wanted this semicircle. So this is pi r square by 2. So this pi will be this. And r was 2 by pi whole square. So this is the flux. What is the EMF then? EMF is basically d phi by dt. So 2 by pi 15t square plus 16t, and the final answer is, what they asked, what is the current? Acha, can anyone tell me what is the direction of the induced current? Can you see this magnetic flux is basically increasing with time? Every term is basically positive, right? So this magnetic field is increasing with time. If this is increasing, then B induced should be acting into the plane to decrease this thing. And for that to happen, the current I induced shall flow till I induced shall flow like this, right? Are yes, sir.
Yes.
So basically, this is the EMF which is induced. Achha, let's try to find out what is the value of this T. 2 seconds. This will be 2 by 5, 15. T square will be 4 plus 16 into T. That will be how much? Can anyone calculate this for me? 60 plus 32, 92. So 2 by pi into 92. What is it? 194. So can you see this EMF was trying to flow the current in what direction? The EMF was trying to flow the current in what direction? In the clockwise direction. Whereas this EMF, this battery 20 volt was trying to flow in the anti-clockwise direction. So both are opposite, right? So when both are opposite, the net current inside here will be E, this E, minus E, that E. divided by, it will be 194 by pi minus, I changed it to 20, so 20 divided by r, and this is the answer. Clear, guys?
Yes, sir.
Yes, sir.
So with this thing, I did the first part of electromagnetic induction is over. I did till JEE mains level. Advanced level, I have skipped this part because I told you know that part is they have not asked that portion from the time when the exam became subjective, objective. Sorry. They used to ask when the exam was subjective, but when it became objective, they stopped asking. So that's why I'm not covering that part. Will be in the next class. I'll be covering the induction part, self-induction, mutual induction, and I'll be leaving a little bit early today because even I also have some work to do. So the class for today is still here only. In the next class, we'll be seeing a little bit more, and we'll be covering self-induction and mutual induction. Okay.
Okay, sir.
Yes, sir.
Okay, guys. Thank you
Yes,
very
sir.
much.